Hello everyone, my name is Cecilia and I'm from class Technical B. And today I'll be discussing about coefficient of kinetic friction. So in real life problem, all of the movements are related to friction force, such as walk, run, or drive a vehicle. Friction force is a force that opposes the relative motion. There are three classifications of friction. The first is static friction, the second is sliding friction, and the third is rolling friction. First, I'm gonna explain the static friction. Static friction is the contact force that keeps an object static on a surface. Static friction points opposite the direction in which the object or force applied, which it can prevent an object from moving or sliding from the surface. The coefficient of static friction, denoted as μs, is usually higher than the coefficient of kinetic friction. The example of static friction is when a car parked on a hill. Next is sliding friction. Sliding friction is a kinetic friction that creates resistance between two objects sliding against each other. The example of sliding friction is skiing on a board. The last one is rolling friction. Rolling friction is a kinetic friction that creates the resistance when a body such as ball, tire, or wheel rolls on the surface. The example of rolling friction are when a car starts to move, the tire will produce rolling friction. So, sliding friction and rolling friction are known as kinetic friction, which tends to slow down when the sliding motion of an object touches the surface. Next, we'll proceed to the questions for the coefficient of kinetic friction. In the first question, a force of 35 Newton is required to start a 6 kg box moving across a horizontal concrete floor. A. What is the coefficient of static friction between the box and the floor? B. If 35 Newton force continues, the box accelerates at 6 meters per second square. What is the coefficient of kinetic friction? So before we start to solve the questions, we're going to draw a free body diagram for the box. Since the box does not accelerate vertically, thus the normal force is equal to mass times gravity, which we know it as weight. So for part A, we are going to find the coefficient of static friction between the box and the floor. And we're going to find the net force in x-axis. And to find the static friction, the net force in x-axis was assumed to be 0 due to the object is static or not moved. And as you can see in the free body diagram, the friction force and the applied force are opposing towards each other. Thus, sigma Fx equals to applied force minus friction force equals to 0. And next, we are going to move the friction force into the left side, which we can simplify that applied force is equal to friction force. And because the box was assumed to be static initially, thus the friction force can be simplified as coefficient static friction times normal force. And as we said before, since the box does not accelerate vertically, thus the normal force is equal to mass times gravity. And we can simplify that applied force is equal to coefficient static frictions times mass times gravity. And from the equation that we got before, we can state that coefficient static friction equals to applied force divided by mass times gravity. And next we are going to input the value of applied force, mass of the box, and gravity, which are 35 Newton divided by 6 kg times 9.8 meter per second squared, which we can get that coefficient of static friction between the box and the floor is 0.6. So next we'll proceed to the B part. And for the B part, we are going to find the coefficient of kinetic friction. And because the box is accelerating to the right, then the pulling force and the frictional force are not stable enough. Then sigma F is equal to applied force minus frictional force equals to mass times acceleration. And the frictional force, we can substitute it as coefficient kinetic friction times normal force. After that, the normal force, we can substitute it as mass times gravity. And from the equation that we got before, we can get that coefficient kinetic friction equals to applied force minus mass times acceleration divided by mass times gravity. After that, we are going to input the value of applied force, mass of the box, acceleration, and gravity, which are 35 Newton minus 6 kg times 0.6 meter per second square divided by 6 kg times 9.8 meter per second square, which we can get that the coefficient of kinetic friction is 0.53. Next, we'll proceed to the second question. Suppose you are standing on the train accelerating at 0.2 gravity. What minimum coefficient static friction must exist between your feet and the floor for you to not slide? So before we solve the problem, we are going to draw the free body diagram. And to find the minimum coefficient static friction, you can say that the static friction must be greater than mass times acceleration. And the static friction can be substituted into coefficient static friction times normal force. And then the normal force can be substituted as mass times gravity. And we can simplify that coefficient static friction times mass times gravity must be greater than or equal to mass times acceleration. And in this equation, we can cancel out both of the mass, which we can get that coefficient static must be greater or equal to acceleration divided by gravity. And we are going to input the acceleration, and in this question the acceleration is 0.2 times gravity, which we can get that the minimum coefficient static friction is 0.2, which for you to not slide. Next, we are going to proceed to the third questions. In figure 1, the coefficient of static friction between mass A and the table is 0.4, whereas the coefficient of kinetic friction is 0.3. A. What minimum value of mass A will keep the system from starting to move? B. What value of mass A will keep the system moving at constant speed? So before we solve the problem, we are going to draw a free body diagram for the box. And for the part A, the net force in mass B is equal to tension force minus mass B times gravity equals to 0. And we can simplify it as tension force equals to mass B times gravity. And next the net force in mass A is equal to tension force equals to static force. And the static force can be simplified as coefficient static force times normal force. After that, the normal force can be substituted as mass times gravity. And we can say that the tension force is equal to coefficient static frictions times mass A times gravity. And for part A, where we are asked of the minimum value of mass A to keep the system from starts to move. So coefficient static friction times mass A times gravity must be greater than mass B times gravity. So we can simplify that mass A must be greater than or equal to mass B divided by coefficient static friction. Next, we are going to input the value of mass B and the coefficient static friction, which are 2 kg divided by 0.4. And we can get that the minimum value of mass A to let the box to start move must be greater than 5 kg. Next, we'll proceed to the B part. So, in the mass B net force in mass B is equal to tension force equals to mass B times gravity, and which is the same with the part A. However, the net force in mass A is different from the part A, since the tension force is equal to kinetic force, and the kinetic force can be simplified as coefficient kinetic frictions times normal force, and the normal force can be substituted into mass times gravity, and we can get that the tension force is equal to mass B times gravity equals to kinetic frictions equals to coefficient kinetic frictions times mass A times gravity. And from the equation that we got before, we can simplify that mass A is equal to mass B divided by coefficient kinetic friction. And we are going to input the value of mass B and coefficient kinetic friction, which is 2 kg divided by 0.3, which gives it 6.7 kg. Next, we'll proceed to the question 4. A 6 kg box is at rest on the table. The static friction coefficient between the box and table is 0.4, and the kinetic friction coefficient is 0.2. Then, a 30 Newton horizontal force is applied to the box. What is the best estimate of the magnitude of the box acceleration? So, before we solve the questions, we are going to draw the free body diagram for the box. And in this question, we are going to find the acceleration of the box. Since we are going to find the acceleration of the box, we are going to use the kinetic friction instead of static friction. So we can say that the applied force minus kinetic friction equals to mass times acceleration, and the kinetic friction can be substituted into coefficient kinetic frictions times normal force, and the normal force can be substituted into mass times gravity, and we can simplify that applied force minus coefficient kinetic frictions times mass times gravity equals to mass times acceleration. And from the equation that we got before, we can say that the acceleration is equal to applied force minus coefficient kinetic force times mass times gravity divided by mass. And we are going to input the value of applied force, coefficient kinetic friction, mass of the box, and gravity, which are 30 minus 0.2 times 6 times 9.8 divided by 6, which gives us the 3 meter per second square, and this is the acceleration of the box. And that's all for today's lesson. See you tomorrow and goodbye.